Cermark laser marking materials manufactured by Faro Corporation are materials that can be used with the laser to produce permanent, high-contrast marks on a variety of substrates. They can be used in a decorative fashion, such as in the trophy, awards, and custom gift industries, or in part marking applications, where they can be used to produce high-contrast marks such as serial numbers, barcodes, or text for man-readable or automatic identification applications. This video will outline the lasers used for this type of marking, how the LMM6000 marking material is used, and how to use the Cermark laser marking tape materials. First, we will discuss the Co2 plotter style laser system. The Co2 plotter style laser system is the machine that is most commonly used by the people in the awards and engraving industry. The laser produces its energy by a tube located in the rear of the system. The laser energy exits a window at the back of the marking chamber and is redirected to the marking head by a fixed mirror system. The marking head contains another mirror which redirects the laser energy through a focusing lens down to the part being marked below. The marking head moves like a plotter, directing the beam downward over a fairly large marking area. The marking head directs the beam in a fashion similar to an inkjet printer head. The marking material is bonded to the substrate everywhere that the beam strikes the object. The beam-steered YAG laser. The beam-steered YAG laser is more commonly used in direct part marking or in industrial applications. The beam is produced by a laser crystal and then is directed to the marking surface by moving mirrors. The mirrors are attached to galvo motors, which can move the mirrors very quickly. This system is more expensive, but can provide much faster marking speeds. The fiber laser system. The fiber laser system is similar to the YAG in wavelength and beam delivery. On this system, the light is produced by a ytterbium fiber located in the center of the unit. The beam is delivered to the marking head via a 25-foot long fiber optic cable. This allows for remote mounting of the head. The head is constructed similar to the YAG system. Mirrors are mounted to galvo motors inside the head, which direct the beam through the lens and down onto the substrate to be marked. The compact size of this particular marking head allows for mounting in any orientation, in small areas, or even on a robotic arm. Marking is done in a fashion similar to the YAG system, with the part located below the marking head. As in the YAG system, very fast writing speeds are achievable. These laser systems are also very durable, with mean time between failure rates of well over 40,000 hours of continuous use. Using the Cermark marking materials. The Cermark marking materials are supplied in plastic jars in a liquid paste-like form. The LMM6000 is supplied as a thick paste. Thinning the material will be necessary before use. Ethanol or denatured alcohol is recommended for thinning. Use 1 part of ethanol to 1 part of LMM6000 by volume. Stir the material thoroughly to an almost water-like consistency. The LMM6000 can be applied by brushing it onto the substrate. A foam brush should be used to eliminate brush marks caused by bristles. Apply a thin, even layer in consistent, smooth strokes. The best results will be obtained by spraying on the marking material. This can be done by using equipment such as an artist's airbrush or a conventional HVLP spray gun, similar to those used in auto body repair. In this example, a metal mixing blade will be laser marked using LMM6000. The surface to be marked must be free from dirts and oils. The surface should be cleaned with solvent before application of the marking material. Apply the marking material in smooth, even strokes. Take care to apply an even, thin film, using only enough material to hide the surface of the substrate underneath. A light coating will deliver the best laser marks. Drying the marking material. The LMM 6000 will air dry in about 2 to 5 minutes depending on conditions. Drying can be accelerated by using a fan, a hairdryer, or a heat source. With these methods, the marking material can be dried in seconds. The material must be completely dry before laser marking. Laser marking. Once the material is completely dry, the object can be marked. Marking settings will vary depending on the laser system used, the optics employed, and the density and size of the object being marked. Removal of excess marking material. The marking material will only bond where it is struck by the laser. Excess unbonded material can easily be removed by brushing with plain water. Properly bonded LMM 6000 will result in a high contrast, extremely durable black marking. Using the laser marking tapes. Cermark laser marking materials are also available in paper film form. A paperback tape is available in rolls for use with CO2 laser systems to mark on steel. A laser transfer film, available in rolls or in the die cuts as shown here, is also available. This film is used on YAG or fiber lasers for marking on glass or ceramics. All of the tapes are self-adhesive and are used by simply peeling them off and sticking them to the substrate. When using the paperback tape, be sure to press the tape firmly down onto the substrate. Any air bubbles must be smoothed out. Trapped air could result in inconsistent marking. The laser transfer films must be carefully applied. Adhesive is present only on the outer edges of the films. This produces a gap between the film and the substrate, which is necessary for optimum performance of these films. When applying these films, care must be taken to press the film down only on the edges. This will ensure that the proper gap is achieved. When laser marking metal with the paperback tapes, the paper will be burned during marking. Adequate ventilation should be used, exhausting to the outside of the room. When using the laser transfer film, the YAG or fiber lasers do not burn the backing material. Laser energy passes through the film and transfers marking material across the gap to the substrate. After marking, the tapes are simply peeled back off of the substrate. With the paper tape, there will be pieces missing from the tape. Parts of the tape may be cut out, such as when marking an O, an R, or a 0. These pieces can be easily removed. Wiping the mark clean with solvent may be necessary to remove char or burned materials. With the transfer films, no burning or cutouts will occur. Simply remove the tape and wipe the mark clean. Cermark laser marking materials.